Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 year CBSE Board Chemistry questions part 22, in which we are going to discuss about the aldehydes, ketones and carboxylic acid chapter. Here the first question is test to distinguish the following pairs, that is benzaldehyde and benzoic acid. First of all, we have to write the structure of benzaldehyde and benzoic acid. So I have to write the structure of benzaldehyde. This is CHO. It is a benzaldehyde. So benzoic acid, what is the structure? So it's nothing but COOH. Okay. So if it is COOH, you'll be getting benzoic acid. If this reactant, so if it will be reacting with, sodium bicarbonate, NaHCO3. By that way, it will give carbon dioxide as a good effervescence. Okay, so it will give this reaction with the sodium bicarbonate, but when it does react with sodium bicarbonate, NaHCO3, there is no reaction. There is no reaction will happen. That is a good test to identify a benzoic acid as well as benzaldehyde. Are you able to understand? Here is the acidic group. We have to find out the acidic and aldehyde functional group. So distinguish the aldehyde functional group from acidic group functional group by the way of reacting with sodium bicarbonate. It will give a brisk effervescence to liberate carbon dioxide. That's what it will be confirmed with that test. And propanal and propanone. What is the structure of propanal and propanone? Propanal, they are giving propanal CH3, CH2, C double band OH. Okay, but in the case of propanone, CH3, C double band O, CH3. This is a propanone. Are you able to understand? Here, as we discussed earlier, so COCH3 group is presence is there, so we can able to identify very easily with the help of iodoform test. Form test. So, you are able to understand, which will give yellow color precipitate, when it is react with sodium hydroxide and iodine. If it is react with NaOH and iodine, in presence of NaOH with iodine, it will give yellow color precipitate. That confirms the presence of COCH2 group, that is a methyl ketone is present. So, and aldehyde will not respond for the above test. So aldehyde will not respond for the above test. That is what it can be distinguished from ketone. The next one is aldehyde, that is acetaldehyde is more reactive than ketone. So we have to write the structure initially, that is towards to nucleophilic substitution reaction, nucleophilic addition reaction. Yes. So here CN, H plus and CN minus, it will be acting as a strong nucleophile. So here CH3, C double band O and H for the aldehyde. For the ketone, I will be taking CH3, C double band O, CH3. Are you able to understand? So here, if HCN wants to attack, okay, so it will be acting as a strong nucleophile. When it attacks, where the positive charge of carbon is a carbonyl carbon, if it has a positive charge, so then it can easily attack. Okay, are you able to understand? So if it is a negative charge, it has a negative charge, it needs to attack the positive charge. Where the positive charge will be available in this carbon? In this case, C double band O carbonyl carbon will having positive charge. Okay, in this also, this carbonyl carbon having positive charge. Because why it is positive charge? Because it has slight negative, because it is attached with oxygen. That oxygen is highly electronegative, so it is slightly electropositive and slightly electropositive here also. Okay, but in these two cases, which one will react faster with HCN? That is the ultimate question. So here, as you compare this, here it is one methyl group is attached with that. What is the nature of methyl group? It is an electron donating group. Here, how many electron donating groups are there? Here in ketone, we have 2 electron donating groups are there. Okay. But in aldehyde, we have only 1 electron donating group is there. So it need to give less amount of negative charge. That's what here it has slight positive charge. But here, both the methyl group will donate electron to this carbon to make the less positive when compared to this carbon. That is what it attaches very less positive charge. Moreover that it create a steric hindrance which will not able to attack which will not able to allow the nucleophile to attack. That is what this would be having. Aldehyde will having more reactivity when compared to ketone in the case of HCN. Are you able to understand, student? So here in this case, this will come and attack very easily because only one methyl group is there, only one electron donating group is there. That's what it gives very less negative charge to this carbon. But here in this case, this carbon already having positive charge. So if the positive charge is existing, the Cn minus will come and attack easily. But in this case, the 2-methyl group will provide the electrons to this carbon. That is what the positive charges may get neutralized. Very less amount of positive charge is there. Moreover, the steric hindrance will not allow the attack to Cn. That is what this aldehyde will react faster when compared to ketone. But in this case, acetaldehyde is more reactive towards to HCN when compared to acetone or propanone. Next one is test to distinguish propanal and butanone, but2-one. So first of all we have to write the structure. Propanal CH3, CH2, C double bond O, H is there. Okay. But2-one, how we can write the structure? CH3, CH2, C double bond O and CH3. As we know that, so here let's do, what is that, Tollens reagent. If I put Tollens reagent, okay, Tollens reagent, the Tollens reagent will give the test for aldehyde, which will not be responded for ketone. At the same time, if you do other tests like iodoform test, what is iodoform test? Let's talk about in the second question, we talk about the iodoform test. If it is react with sodium hydroxide and iodine, which will give yellow color precipitate, that yellow color precipitate will give the information about the methyl ketone, existence of methyl ketone in the compound. Are you able to understand? Either we can do iodoform test or we can do silver mirror test. So if you react with the Tollens reagent, it forms silver mirror, AG mirror test, silver mirror test. So you will be getting silver mirror test, but it will not be responding for, this will not be responding for Tollens reagent, and this will not be responding for iodoform test. Okay. And next question is give the reason, that is the pH of a reaction should be carefully controlled while preparing ammonia derivatives of carbonyl compounds. This question was asked in the year of 2013. It plays a very important role here. Why to study? So here the carbonyl compounds, this is the carbonyl compound, C double bond O. Okay. Carbonyl compounds will, the pH of the components, the reactant should be maintained carefully. Why we have to control? Because ammonia, if I am taking NH2, NH2, you consider this is one of the ammonia derivative, that is a hydrazine if I am taking. So why it will be acting as a base? Because ammonia will be acting as a base. Why? It donates a pair of electron. So it donates a pair of electron, that is what it will be considered as a base. Okay. If you are not maintaining the pH, okay, if the pH is very low, if pH is very low, at that time this ammonia derivative will be acting as a base. Okay. If you are maintaining pH is low, that is acidic. Okay. These acidic and these basic will react together. So these two react. Okay. But it will not react with, this will not react with, what is that? Carbonyl compounds. So we have to maintain the pH in a basic medium, then only the reaction will happen. Are you able to understand, student? So here, if you decrease the pH value, it becomes acidic. If it becomes acidic in the sense, it reacts with a strong base. So base is ammonia, ammonium compounds, ammonia derivative. The ammonia derivative will be able to react with acidic environment, okay, and which will not able to react with this carbonyl compounds. So if it is not forming a carbonyl compounds, there is no use of producing ammonia derivative compounds with aldehydes and ketones and carboxylic acids. Okay, so that is what we have to maintain the pH of the reaction carefully controlled while preparing ammonia derivatives of carbonyl compounds. Are you able to understand, student? And next one is arrange the following compound for the reactivity towards a nucleophilic addition. Here also the same thing. We have to check with that structures. CH3, C double band OH, ethanol, propanal, CH3, CH2, C double band OH. This is the propanal. What about the propanone? CH3, C double band O, CH3. This is the propanone. Butanone, they are not giving any position so that we can able to write anywhere else. So CH2 and CH3. So this is the butanone or butone. Okay, are able to understand, students? This is very important one. So here, as we know that here we will be very clear. So nucleophilic addition reaction will happen if the positive charge is maintained, because Cn minus will be, suppose if I am taking HCN or KCN, so the Cn minus will be acting as a nucleophile. The nucleophile wants to come and attack a positive charge. If the positive charge will not be maintained at the time, the reactivity is very less. So here only one methyl group is there, so it has some positive charge. Here 2 methyl group is there, so it has less positive charge. And here also 2 methyl group is there, here also less positive charge. Here you compare in both side, number of electron donating groups are there. That is what it creates less positive charge. According to that order, this will be having more reactivity, and this will be reactivity, and this will be reactivity. Are you able to understand? So the least reactivity is butanone, and the next one is the propanone and propanal and ethanol. So ethanol is the most reactive one towards to nucleophilic addition reaction. Are you able to understand? Because of less electron donating group, but in this case more number of electron donating groups are there. That is what here one side electron donating group, because here 2 side electron donating group, here much more electron donating group in both the sides. That is what it is a less reactive one. And next one is the test to distinguish acetophenone and benzophenone. First of all, we have to write the structure of acetophenone and benzophenone. So acetophenone, as we know that when it will be called as a phenone, one keto group which will be which will be attached with alkyl group and aryl group. That time it will be called as the nomenclature should end with phenone. So if it is a acetyl group, that is will be called as acetophenone. So if it is a aryl group, that will be otherwise called as a benzophenone. Okay. So how we can distinguish? So it is also very simple, because here also the methyl ketone is existing. If you do iodoform test, so which will be responding, the iodoform test which will be response for this acetophenone. But in the case of benzophenone, which will not respond it for iodoform test. So iodoform, if you do iodoform test, what we know that, so there is no reaction, but here it will respond and to form yellow color precipitate. It is be obtained in this case of acetophenone, because of the presence of COCH3 group. It will respond it for iodoform test. Iodoform test is nothing but there will be a presence of NaOH with iodine. So NaOH and iodine will react to form yellow color precipitate because of the presence of COCH3 group. But in this case, COCH3 group is not there. That is what which will not be responded for iodoform test. Are you able to understand, students? So here, thank you so much for watching. Please go forward to others to get benefit. Thank you so much. Thank you once again.